This is lesson 413, expanding the trig table. So in this lesson, we're going to be adding some more trig identities to our toolkit. Visualize what would happen to a triangle if the slope angle increased to 55. Well, first they want us to draw a triangle with the slope angle of 45. We know that that's a 1/1 ratio, so we just want to make sure it's got a slope of 1/1. So that's about a 45-degree angle right there. Now, if it was 55 degrees, it would be a steeper angle, right? So maybe a little bit more like that would be 55 degrees. Let's make these the same colors so we don't get confused here. Okay, so that's more like 55 degrees. So if we made a slope triangle like that, it seems like our change in y is bigger. So the change in y would be longer than the change in x. And because here, this is a length of 5, 1, 2, 3, 4, 5, 6, 7, a length of 7 there. About. That's just kind of a guess for what 55 is, but the change in y is longer. The goal of this is to create the slope of a 55 degree slope triangle, and this is, I'm just kind of going to skip through this. This is about 1.428. Okay, so we can add that to our trig table, 55 degrees. The change in y is going to be longer. 55, this is about 1.428. So using that, they want us to find the triangle below. So change in y over change in x, this is 8 over x. And again, we just learned for 55, this is equal to about 1.428. I'm going to put this over 1 so I can cross multiply here. So 8 equals 1.428x. Divide both sides by 1.428, and x is about, we're going to use these squiggly lines because it's not an exact number, about 8.602. So with these problems here, we are going to decide, first of all, whether the given measurements are possible, and if it is, finding the value of x, y, or theta. That would be like the missing angle. We're going to use our trig table toolkit or the slope ratios e-tool, because some of these are not going to be on our toolkit. For instance, 70, we don't currently have that on our toolkit. So what we're going to do is we can go to the slope ratios e-tool. And we can adjust. So we want this to be 70 degrees. So we can change the angle right here to 70. And then, let's see, what was our change in x was 10. So I'm going to change the change in x 10. So 70, where it says delta x, I'm going to change that to 10. Oops. All right, and then it shows us what our delta y is, 27.47. So that change in y is 27.47. And it also told us where it says the slope, that's 2.75 for 70 degrees. So what we can do is we can go back to our trig table. For a 70-degree angle, that's going to be 2.75 roughly for 70 degrees. Okay. All right, for this next one, we're looking for theta, and we have a change in y of 50 and a change in x of 6. So we can go find 6 as our change in x. And then we can't change the change in y. We'll have to move around our angle until we get that to be 50 for the change in y. Let's see if I can get a little closer to 50 here. Looks like that's the closest that'll let me get. But that's about an 83-degree angle, okay? Since we're not exactly at 50. So that theta is going to be roughly squiggly equals 83 degrees. Here, 10 over 1. Let's do that again. Delta x is 1. And again, we'll just have to play around with the angle until we can get our change in y to be 10. It's about 84 degrees. So roughly 84 degrees. Okay, so those are what we could add into our toolkit as well. We've got 83 degrees and 84 degrees that we can put in. Okay, so that's about 50 over 6 and 10 over 1. I won't add those to my toolkit right now. For an 8-degree angle, again, we need to go to the toolkit. We're not sure what x is, but the angle is 8 and the change in y was 20. So let's adjust the x until we get to a change in y. Was the change in y 20? What are we looking for? Yeah, the change in y was 20. We're looking for the change in x. Why won't it let me do more? Oh, let's go up to like 100 or something. There we go. Okay. Change in x of 20. All right, so that is roughly, oh, it's a change in y of 20. What am I doing? Oh, so we're playing around with the change in x until we get to a change in y of 20. Man, we still need to go more. Like 200. Changing the x until our y becomes 20. So about there, 19. Oh, okay. That's really close. Oh my gosh, 143 for our change in x. About. Roughly. All right. Let's see. If the side here is 0, that's no slope. That's a horizontal line. There's no angle here. So the angle here is 0 degrees. 89, we don't have this on our toolkit either. Okay. So a change in x of 2, our angle is 89. Change in x of 2. And our y is 114.58. All right, and then finally a 90-degree angle. This is not possible because we have a 90-degree angle here, a 90-degree angle here. We know that the angles in a triangle are supposed to add up to 180. So this mystery angle over here is 0. And we know that 0-degree angles are not possible. So this triangle is not possible. All right, so we definitely have some new angles to add to our angle toolkit. Any of these that you didn't add already, go ahead and add them. All right, so what happens to the slope ratio when the angle decreases? So when our angle is going from here to maybe down here, the slope, think about it, our change in y is on top, our change in x is on bottom. Our change in y is decreasing, which means our fraction as a whole is decreasing. So when the slope ratio, when it increases, so when it decreases, decreasing. When the slope ratio increases, so when we have a bigger change in y, the angle increases and the slope ratio increases. So that's a direct relationship. All right. What happens to the slope ratio when the angle is 0 or 90? So if we think about it like on a grid, a 0 degree slope is just a horizontal line. That's 0 degrees, horizontal. And 90 degrees is right up and down on the y-axis, 90 degrees. And we know the slope of a vertical line is undefined, so that is undefined. And then when the slope ratio is more than 1, so when we have a fraction that's more than 1, that means the top number is bigger. So that's when the change in y would be bigger. When it's less than 1, the change in x would be bigger. So when our change in y is bigger, the slope ratio is more than 1. And we learned that even is a 45-degree angle, right? When they're both the same, they're both 1. So we could say when the angle is more than 45 degrees, and then when it's less than 1, that's when the angle is less than 45 degrees. All right, that is all.